Um, yeah, hi. Um, I think I'm audible. Yeah, volume is max. Yeah, in this stream, I'm going to discuss about semantic search and some of the lead code questions that is solved today in today's weekly contest. Let me share my screen. I think I'm very excited for this stream because I really enjoyed a lot. 1 second. Yeah. Let me share my screen. I think my screen is visible. What is the problem? Um, Semantic search, right? So um let me come across like when why does what's the need of this semantic search, right? So when this the when LLMs got was getting adapted more into tech industry and everyone are getting familiar with the usage of LLMs and its diverse use cases. So I think around quite some time back, not too far away, like nearby only. So the concept of RAG came up, like retrieval augment generation, where from the dynamic knowledge base, you pick up some relevant information for your query or user query and pack them like the user query and the relevant chunks, send it LLM, ask whatever you want to do it, like maybe processing the thing and generating output, or ask LLM to find some information in that relevant chunks or something like that. It just goes as a context. The question plus chunks goes in the as a single in the single context window, right? So it gets processed in the same, like everything gets processed at the same time. So that's what, like, so we have vector databases. So maybe ChromaDB, Pinecone, Waviator. I think Gemini is suggesting very good. Milvus, yes, and very famous and my favorite, Elastic, Elastic Search or Elastic, whatever. I doesn't matter unless, yeah, you know what is it. Yeah, Elastic Search, right? So earlier these vector databases used to support only full text search, right? Like, because there were no embedding models at that time. You, if you want some relevant documents or relevant chunks or relevant information for your query, you used to get it from full text search. That we have seen in my previous streams, how search engines like Elasticsearch or some other um providers, how do they score, or how do they give you results for your search query, right? So that is not enough, right? Because there are semantically related things, and if you want to read more about why does semantic search matter and what actually is semantic search and what is the term in by semantic, you can read about it. It's nothing, it's not that complicated. It's just like the relation between it's semantically related, right? Like meaning wise it's related. So yeah, wha- you are fetching some of the chunks using full text search or keyword search, and what if you fetch, you need to, ultimate thing is you need to gather information. Goal is to get as much as related info regarding user query. This is our goal, right? No, yeah, this is our goal. Yeah, this is our goal. So currently keyword is not enough. it's not keyword is not enough. um Apart from keyword, if we get some kind of search that fetches some info which could not have been fetched via keyword search. Like semantic search might return some info which you couldn't fetch from keyword search, maybe because of the number of results that you are fetching from keyword search, or maybe the keywords that you are looking or phrases that you are looking is not present in that info, whatever is the reason, right? So then comes our hero, semantic search. So nothing like semantic search, uh, to maintain its semanticity, right? Like the meaning wise same between two different phrases or whatever. So these guys generated something called as embedding vectors, where the phrase or a word or any even a single letter or whatever emoji, I think an emoji can be done as embedding. Haven't tried, but I think it should be done as embedding, because ultimately a emoji is inside internally is a combination of two or more characters. Yeah, I have read this when I was learning Swift. So yeah, like you have two embedding vectors of two queries q1 q2, and in an n-dimensional vector space, or whatever is the dimension of the vector embedding vector. So let's say there is a vector q1. I don't know how can I visualize it. There is a vector q1 and there is a vector q2. If these two vectors are closer to each other, that means they are semantically related, and if they are very far away, they are not semantically related. That's as simple as that. And yeah, like what is the criteria, right? Criteria for, I don't know if this is a word or called nearness. Like I don't know what's the criteria for nearness. Distance between vectors, cosine similarity. Like the angle between these two vectors are too close, then it's more intuitively say, it can be intuitively said that they are semantically related. And how does this, the representation of vector with the representation of another query will be made as semantically, is like that's the magic behind embedding models. Yeah, I don't have much idea how they generate these things internally. I don't know how they work internally as of now. Just imagine it's like a black box. You feed it some data, and in return it gives a whatever dimensions that you are using embedding model, right? Maybe 384 or 786. Yeah, even these numbers I'm not sure. I remember it's 384 or 300 and 700 something. So it's an array basically. Yeah, I think these are all this. Why to? I don't want you to scare. Even I'm scared after seeing this. What is this Jacquard? Yeah, I think these four are. I think we are all familiar with this. What are these distance and how these metrics are measured between two vectors if you are given. So right now, yeah. Yes. How now? Vector DB providers has adopted it because it's in demand, right? Like RAG is in demand, like from I think more than 2 years. RAG is in demand, and yeah, if they want to grow as a business, they have to adopt it, and they have to provide. They have to tell that yeah, this is a semantic search that we implemented. You guys just use it as a tool. Vector DB providers have adopted it. So let's see how does that work. Okay, what is happening? Okay, yeah, I just wanted to draw a margin, right? You should draw margins. So yeah, um, so let's say you have stored information. Let's talk about Elasticsearch, right? Let's talk about how Elasticsearch implements semantic search. Yeah, let's talk about how Elastic. Um, so there are certain number of fields that you can you can give while creating an index. So one of the field is you can call it as vector and declare it as dense vector with dimensions, right? So let's say you have a chunk um, in the index. I'm um, I'm referring a document or the piece of text that reside in each document as a chunk. So before storing the chunk, embed the chunk using an embedding model. What happened? Okay, sure. That's why shortcuts are not good for life. So yeah, embed the chunks using an embedding model and store it in vector field, right? Okay. Now when new user when new user query comes in, as I think in my previous streams I would have mentioned about this, or if not, uh, this is like whatever you are doing on the data while processing it and storing it, the same processing steps should happen for your query as well. So in order to see, here you are dealing with vectors, right? If you are dealing with vectors, your user query also should be converted into vectors. So embed the user query using embedding model. Use this to search in vector space. Return top k results. So vector DB providers will ask how many results you want per query. It's variable as per request. If you want 50, Elastic will return you 50 chunks. If you want 100, it returns 100 chunks. If you want 10, it returns you 10 chunks. Now it's simple, right? Like you have now you have vector v1 and vector v2. Do cosine similarity of v1, which is query vector, with each vector in vector db. Rather than this index, yeah, you have a query vector and there are multiple vectors in each chunks. Just do cosine similarity of this with this with this with this of each one of them. Sort the results in descending order, maybe on the basis of how close they are, and return top k results. This is what we do. If I want to show it, let me share my screen. How to code explain in interview. My lead code is down. Um, Sir, how to code explain in interview. Um, Even I'm not good at it. Like, I have given multiple interviews, but yeah, I think I'm not that eligible to answer that. I cannot tell, explain your code in this way, you'll get accepted, because I know, yeah, I'm less experienced. My lead code is down. I think my lead code also is down. It should be for everyone. Yes, I think even my lead code is down. Okay, let's not trouble them. I think they're in uh, guessing if there might be in Christmas vacation. So let me reply to you, right? Even my lead code is down. Yeah. Um. Yeah. Like Vinay, I think I don't know how to explain code in interview. I have given multiple interviews, right? But yeah, I cannot tell anything to follow because I'm not that senior in this. I think okay. How I do is whatever comes to my mind, I just let that out. Maybe it's your thinking process. It's fine to be. It's fine to code incorrect in interviews because there's a something called as peer pressure. But yeah, it's fine. You ultimately they will check your thought process. Yeah. Where am I? Yes. Drop ad online. Okay. Okay. Text. Pen. We want pen or I think pen is too much, right? Yeah, I think this much will be fine. Yeah. So this is my vector v1, and this is my each vector in each vector in vector db like this. I am doing dot product. Let me decrease the price size. I'm bad at it. Sorry. I'm doing dot product with this, with this, with this, with this, which each of the index. I think this is our index, right? This is our index. I don't know. Like this is the first time I'm using. I don't know. Let's not too much worry about this because I don't know. Yeah. Yeah. I think yes. This is our index. Yeah. It should be good. This is our index, and these are the vectors in our index, and this is the query vector. Let's decrease the size. Okay. Let's not. Yeah. This is my query vector, and I'm doing the dot product with each of the this thing. So for every dot product, I get some score, similarity score. Maybe it's the I think v1 and v2 cosine similarities v1 dot v2 equal to it's is it okay? What is dot? Okay, mod v1 into mod v2 by cos theta into cos theta. I think dot product. Yeah, I think yeah divided by modulus of v1 into modulus of v2 cos theta. So yeah, and this is 784 dimensional vectors, like 784 into 784, each array element you are doing this dot this, something like that. So yeah, that is how this is. And if I, yeah, that is how it calculates, and it returns you the top things. Like here, there is nothing magic done by embedding model. All the magic is done by your embedding model. No, nothing magic is done by vector databases. The entire magic is done by the embedding model of which generates this query vector, and embedding model which generates these each query chunk, right? Now let's discuss the other side of this. Now let's discuss about um, cons, right? Because not conclusion. Okay, why am I here? Let's discuss about cons, right? What is what is wrong in this? Like why this is not good? Let me tell with an example. I was working on a project where I was, instead of using retrieving, fetching some chunks from Elastic Search using Semantic Search. Everything was good. Like everything works for different. Everything worked fine. Different with this is. I think this is called as, in terms of Elastic terminology, this is called as similarity score or similarity search. This is like brute force thing. So yeah, coming back to this, everything was fine until I was just running. I was seeing how well my documents are fetched. I ran the query, and I saw the error, connection timeout. It used to work for before for thing. Nothing changed, no code change, nothing. Just I changed the index name and I got connection timeout. I pinged to that index and the index is existing. I verified that. But why did this come? Why did this come or came? I don't know. Why? I don't know. I'm bad at English. Yeah. Why did this come? Like it's not comes. It comes. That much I know. Why did this come? Because there are 1.2 m chunks in that. Okay. Why confusion? Million chunks in that index. There are 1.2 million chunks in that index, and this is big of n, right? Like best case, like into I think 786 or whatever the dimensions of the vector. I'll tell you why. When I mean to say why big of n, because assume there are 1 million chunks here, and the vector is 786 dimension here of this and this. For each chunk, I am doing again the calculation of dot product on the array of say 786. 786 into 1.2 m is the time complexity of this entire calculation, which is I don't know if you are able to convert that into seconds, which is more than probably 30 seconds or something like that. And this brute force calc takes 30 seconds, but connection to Elastic index from Elastic client is 10 seconds. Yeah, that's why I was facing this, right? Like that's why I'm facing connection timeout. So that's why it is timing out. Now for the case of like making this work immediately or escaping this, I could have increase timer to 60 seconds, but that's a very bad practice. Making a constant established connection of 60 seconds is very expensive, because I think database connections uses TCP protocols, and making a TCP connection open from the server side, it's a very costly it's a very costly thing. It's not, I don't know the exact reason, but yeah, making connection for 1 minute with the server and client is a bad thing, right? Until and unless you are long polling or short polling, whatever. um, but this is not designed for that, right? It's not, this is just a request response model. So yeah, like, how can I optimize this? This is a question. Now currently it is taking, for instead of going to for each thing, can I pick some chunks somehow relevant to my thing? But how can I pick the exact k or top how many that user has requested from the existing 1.2 m chunks? um, yeah, elastic, I think uh, there is something called as HNSW. Again, I am very bad at English and spelling, ignore me. Hierarchical small navigable world, it's a graph. Yes. For the, like, I think this is a very great debate, um like, is DSA used? Like, they simply ask in interviews, but you'll be seeing memes, right? Like, they ask me to invert a tree or ask me this specific graph problem or DP problem, but actual work they're asking me to just build an API or do API calls, or even lesser than that, whatever, center a div or something like that. Yeah, this is where the data structures comes in, and in order to use the data structures, you need algorithms, right? Because graphs, it's a graph. Yeah. So everything that everything that if you see, if you deep dive into low level, and if you see what is running all that abstracted tool or whatever you are using, Redis cache, like, it uses linked list inside internally to hold your data. That's how you are able to do operations, right? Like, frequently used you're putting on the top, and you're removing unfrequent things. The operation should be quicker. That's the thing of cache, right? They use doubly linked list internally, and yeah, so many things like that. Search engines uses map data structure for inverted index, upon which your entire that's what you are able to see very quick results in milliseconds. Yeah, ultimately, if you drill down deep internally, everything is a data structure, and algorithm is required to drive a data structure. So yeah, coming to the point, elastic internally uses internally builds rather than index, right? Because it's not, because yeah, I'll show you what is it. So let's go to new. Why are I not getting unlimited story? No, no, yeah. Pencil width should be, yeah, this much is good. So instead of doing the thing with each, right? Why it is so big? Okay, yeah. Instead of doing with each index of querying like this, what Elastic does is, let me undo all of this. What Elastic does is, when you create index and before storing the data, right, it builds some layers. I'm very bad at drawing, please. This is one more layer, and this is another layer. So okay, let me see if I have any comments. Okay, there are two people viewing. Yeah, let's not deviate from. So yeah, let's say you have okay, whatever it is. Say you have 20 documents in the index, right? Okay. Say you have 20 documents in the index, like, and play how this HSNW navigable small world thing works is, say you have a, so this is one vector, this is one more vector, and in each layer you will be having some vectors, maybe this, and here you have many vectors, right? I am unable to draw all, but yeah, here you have many vectors, like nodes, like, forget about nodes, you have different nodes in each layer. So layer 1, this is layer 1, assume this is layer 1. Layer 2, layer 0. So in layer 0, in this layer, right, it's small actually, but doesn't matter, like, just layer wise I wanted to make some things here, so I just drew like that. So in layer 1, assume you have all the documents, like 20 documents in layer 1. In layer 0, sorry, this is called as base layer. In layer 1, you have picked some of these and kept here, and how that is picked randomly, again randomly. In layer 2, um, you have very few documents, maybe 2 documents. Now in each layer there is a relation between, there is a connectedness in each layer, there is connectedness among each vector, like these vectors are connected like this vector is connected to this, and to this, and each vector are connected like this. It's not sure that it's not guarantee that this should connect all of this, because this vector is semantically related to these three itself, like these three vectors. It's not semantically related to this. Same with this, it's semantic, this vector is semantically related to this vector and this vector, this and this. It is not semantically related to these two. That's why there is no edge between these two nodes. And yeah, 1 second, yeah, similarly, this this this, like this, there are n number of connections, right? So yeah, again, the vector from this vector is connected to this vector semantically, here in different layers. This is connected to this is connected to this is connected to this is semantically connected to this. This is that is why the name is hierarchical, mean like layer wise, small navigable world. Like, this is a small world, and you can navigate from one vector to another vector because these two are connected, right? Like again, the graphs and nodes stuff. These two are connected by an edge because they are semantically related. When you have a query Q1, when you have a query vector, when you have a query vector, and now you know vector dimensions of this. So first you will go to one of these two vectors. Let me color. How to color this? I actually don't know how to color, but okay, we can do like this. Yeah. So this is a query vector, and assume now assume you ingested the data, and each node has vector of each document. Like this is a vector of Q1, Q2, Q3, Q4, Q5, and so on Q20. Since we have 20 documents in the index. Now, when you fire a query in the layer two, topmost layer, I am I am this I am at this vector right now. There is a distance between this to this, and let's mark it as d1. And let's mark this distance as d1. Since these three are connected components, like I don't know how to. I need some color. Like, tell me, like someone, how to get color. Paint into layer. No, this is brown. Yeah. Never mind. So this is distance d1, and x1, x2, x3. Yeah. X1 is the distance between these two vectors. X2 is the distance between these two vectors. X3 is the distance between these three vectors. It's a connected one, right? So if my d1, yeah, I think let me drag it to here. Let me put it here. Let me decrease the font size. I don't know. I opened this randomly, but okay. Doesn't matter, right? Like, let me come to the screen. So, like, there is d1, x1, x2, x3. Now, if this distance between query vector and x1 is greater than x3, x2, x1, we consider this node. So let's say now say x1 is less than d1, and also x1 and x2 is less than d1, like let's say these two are closer than the d1. uh, Now I need pen. Okay. Okay, let's say x1 and x2 are close. We are right now at this. We are right now at this. And since x1 and x2 are less than d, these two nodes also closer, right? This one and this one. Now we are at x2. Let's say we marked all these two. Now we are at this node. I don't know. Yeah, we are at x1. These two are close now. Yeah, I think this is a better option. Now we are at this, and the distance between and and again the distance is calculated between the query vector and this, and it is, let's say, d2, and it's connected to 1 2 3 two vectors, and let's say this is closer. We are marking this because it's closer, this distance. uh, Second. Okay, again let me draw to. Okay, my bad. Let me draw from this to this, and let me quickly mark this as d2. So this is d2, and and this again, again d2 is compared with this distance on all its connected components, and say this is lesser. So we come here and we check this. So again the same, the d3 will happen, and we are marking some of this. So let's say we have marked enough. Now we have marked enough like this. um, Now we have marked enough like this to fetch our results. Now out of 20, how many we have marked like this? 1 2 3 4 5 6 7 8. Like this we got 8 chunks, and these are approximate because maybe like this is not exact. There is no exact anything calculation, right? Because this is just based on the basic principle that if the distance from the query node and the existing node is more than the distance between the connected nodes and the existing nodes are also related to the neighboring nodes also related to existing nodes, because existing node is also related to this. It's like a implies b and b implies c, a implies c, and this is also related to this because these two are now common node between this node and this query vector node is this node, the parent node. So we got 8 results approximately, and this process will happen like from here we came here, right? We have never traveled from this. Again distance between this and this might be calculated, and this is marked as d3. My bad. And this can be marked as d3, and the same process will happen for how many, until we find num of results requested by you as developer. So yeah, that is how this efficiently. So tell me time complexity of this, like um assuming like there is assuming this nodes get equally or proportionally distributed in each layer, the time complexity is log n, and the time complexity of our previous thing where we are matching with each query vector, it's n. So this is faster than that, right? So when I changed my search query from the simple similarity search to this, the ANN, this is called as approximate nearest neighbors, because we are approximating these chunks, not exactly the closer chunks. Out of this we can, I will discuss out of this how to get perfect chunks. So when I have 1.2 million chunks, instead of big of 1.2 million, I'm going to big of log of 1.2 million, which is like a magic. I think the connection time of 10 seconds is far higher than log of 1.2 million. Uh, that's why I don't know how to convert that exactly into time, the time complexity thing into actual seconds. But yeah, that's how. After that, my semantic search never crashed. It never gave the same error. And yeah, that's the beauty of the abstracted tools like Elasticsearch, how it does, how they do. I was reading through this wonderful blog from uh, Elasticsearch Labs. They have very, very, very good documentation. So this is the article. I'll link to this, and if you can see this diagram, I think here they represented it very clearly. So when user query is here and there is user query, this is connected to this distance. This distance is less than the query distance. So that's why we traveled here, and from here we it is this is connected to one node. I think this distance also might be less than this. So we went to this, and this is one path, right? Another path we can travel. This is connected to this node as well. If this distance is less than the query vector distance, we are traversing like this, and the blue things are results. We return those results, and we repeat this process um, until we meet number of results asked by the user. So yeah, that's about HSNW uh, graph thing. At the end, these are approximate, not exact semantic matches. Because what is the distribution of this? How they decide these three and these two should be there, and which vectors of 1.2 m documents should be residing in top layer, bottom layer, and groundmost layer. And it's not like all different things, like there are common things. Like if you see, they highlighted this light pink is appearing two times because this is the same vector. Like the each as layer increases, the nodes, the vectors present in each node is a subset of its consequent layer, not somewhere it came for different. It's not like you do unify of this, it will give the complete vector. Like if you do intersection, it's not empty set. Yeah, things are there common between these layers. So yeah, you can there is very interesting thing. And I think because of I don't know. I'm currently exploring how they'll construct this graph based on what they choose this things, what they choose. How do they decide that? Okay, at the layer zero base layer, I agree. All the 1.2 vectors will be arranged like this, and there is a big mesh will be formed among each vector with another each vector present in that layer. But how do they pick some vectors from this and put this, and again they pick some vectors from this and put in top layer? I'm little bit, yeah, I'm exploring that currently. I'll read this and do some research on internet and let you know in the next stream. Yeah, coming to the point, at the end of the day, these are just approximate, not the exact semantic matches. So what you do, okay, we got 100. Now in this less set, we can do costly operation, right? Like which is similarity score. We can do this, right? Because at the end of, like, let's say you got 100 from this, and maybe depending on your embedding model and size of the chunk that you decided. So say you want to return 30 chunks, and get 100 or 200 from this, and upon this 200 do actual cosine similarity match, like do the query vector match with the 200 vectors in this set, and then pick top 50 from that. This is the actual exact semantic matches. Then pick top k from these approximate matches. There are so many things, like let's say now I have 1.2 m 1 million chunks in this graph. How does graph restructures when you add 10 more chunks into db? Like I can add any number of chunks, right? How does the graph restructuring happens, and how does that vector changes in each layer happens? And yeah, I'm currently reading that on that. Yeah, this is on the semantic search. um yeah, like, yeah, I'll share this text field, or I think this is not that much. You can read this article. This article is main. And also this, what is knn, and for reference, how do I, okay, this is not can I, anyway, it's I, with most difficulty I kept it right. Let me check if I can paste images into this. I think I'm not able to paste it. No, I think I'm not able to paste it. Yeah. uh, yeah, it's fine. Like this is not that much of artwork. You can get this many things on the internet, or LLMs can generate this. So yeah, that's how semantic search works. If you know this, how internet happens, go to Milvus. Let's say you are working on Elastic, suddenly project change to Milvus. It's simple. Like at the end of the day, you're gonna use just the functions that they're providing. But if you know what's happening in the underhood, it's very easily to get adapted to the functions and abstracted stuff. So do not much bother about what framework or library you are using. Just get to know, or at least up to some level. Like I don't know, maybe if I start seeing all this, like how factoring happens when I add 5 more index, I think my head will be like boom. I'm not that, I don't know, I might not understand it at all, but still, like, that at least something happens, right? Something is happening, like, rather than at least some, you have some idea. And this restructuring is like heavy mathematics, that um yeah, it's a PhD thing, not even masters or BTech. It's a PhD shit. So yeah, it's a result of years of research and like that. So yeah, like data structures, algorithms, like DSA. Like if people ask, DSA is not being used. It is being used. You are just not part of it. If you work maybe in Elastic Search company or Elastic organization, and if you are lucky enough, you might get into this team who are developing these algorithms, like who are converting this, handling this at the disk space level. Like all this refactoring, restructuring, creating this will happen in your ROM, like somewhere in your data center or cloud, where your instance is residing. Maybe in Dallas, US South region, in the data center, in small, you'll be given a small server where your Elasticsearch instance is running with some 60 or 70 GB of RAM, and in that everything is happening. Like you see the lower level of programming that those guys does. And yeah, that is like next level of engineering. Using Elasticsearch is not a big task, but building Elasticsearch is a, yeah, well, it's like out of the boundary. Yeah, that's it for this. I think it's a good amount of content here. No, I'm not showing running the things, fetching chunks from Elastic, that I think even LLMs can generate. um like it can quickly generate. Even I cannot, I don't have it handy now. Even if I want to show, I have to go to some LLM like ChatGPT or Gemini and generate and explain how is this happening, this is working like that, like that, so that you can explore by yourself. So yeah, let's see, let's discuss about As the title, what's the title? I think I should have changed the title, right? What's the title? I forgot. I think I added weekly context discussion. So yeah. Okay. For 82. Yeah. Yeah, lead code is working. Yes, it is working. Lead code is working. Why is it running for 262 hours? Okay. Yeah. Let's quickly discuss about. I don't know. Maybe by this time, uh, some YouTube channels or someone would have already posted. I just don't want to waste much time on this. Um, and also I'm not master of it, so yeah. And let me, instead of discussing about this, let me quickly walk through this and see. Okay, let it be. I can explain the code here itself, right? So this is the first question number one. The question number two. The question number three. Yeah, yeah, today I was able to solve three questions, and yeah, I don't say it's pretty good contest. And I want to talk about this fourth question, right? Because this is the sixth consecutive or sixth contest that the fourth question is a 7 pointer question, and the fourth question is on digit DP. Like, this is based on digit DP, which I was planning to learn from much time. I read the question. Question seems pretty easy, but if you see the constraints, right? Like, look at this: 10 power 15. How much without digit DP? How much ever you optimize or you think, there's no point. You cannot get it accepted. So instead of adding the penalties, I just left in the contest. I didn't even attempt to try this question. Just 1 second. Yeah, I got notification that someone subscribed to my channel. Yeah, it's good. So yeah, let's quickly. I have some other work as well. I think charging is about to die also sooner. So let me figure that out, right? Let me connect charger and come. Yeah, yeah. Um, where are we? Hi, bro. Hi, hi. Why are you getting this king size, or is it? I don't know. I don't know. Like, the first time I'm seeing the live comment, so I'm excited. No, I don't want to close it. I want to close this. Yeah. So yeah, let's quickly go through each question and see. Yeah, this is, again, I think this is a 4 pointer question. It's a medium mark, but it's, yeah, it's not that medium level. So you're given integer array. Choose an index I. For choose and split index, prefix sum will be sum of from 0 to including this index, but suffix minimum of I is minimum value among from next nums of I to this. And it's like for all split index, return the maximum score. It's straightforward, right? There is nothing much to think about this. uh, since they want to return answer as long, I created this prefix as long, because summation is will get increasing, it might overflow. Suffix will not overflow because it's just the minimum of these two integers. Since the input is num integer, this can be integer. So initialize prefix and populate this by keep adding, and do same thing for suffix but from the opposite direction. Now this also can be done, like, because um yeah, if you see, they wanted to take minimum value among nums of n minus 1, including the last value as well. So if you are at the last, here if you put my first, while I was running initially, for the first run, or I can do is this, I can write here itself. For the first one, I considered n minus 1th element as well. It fails because if you are at last index, and if your suffix means of I plus 1 will return like array index bottom bounds. So because he wants the maximum, the minimum value among all from that nums of I plus 1, whereas he wants the summation till including that I. So here, that's why I didn't write I plus 1. Since I have written I plus 1 here, this should be n minus 1. Same thing, like whatever he asked, I just implemented. It's a easy question. So yeah, like if I would have clicked submit at n, I would have got penalty. But yeah, for at least the test cases, I check if my code is correct. So this is good. This can be skipped. Let's come to this at the last, because it's a little bit implementation and understanding heavy question. In the contest as well, I spent 5 minutes time on reading this and understanding this, and I read at problem number 3. This is small and simple problem, so I came to this to solve this. So yeah, so what is this question? Small, all ones, multiple. So I remember the question actually. So what is problem? The problem says given k, return length of number which only has all ones as digits and k divides it. Return minimum such length. So let's see with one example. For k, 3. So what are the numbers that has all ones in it? 1, 11, 111, 4 ones, and so on. Out of all this, what is the minimum number that is divisible by 3? What is happening? Out of all these numbers, what is the number that is divisible by 3? Does 1 modulo 3 is 0? No. 11 modulo 3? No. 111 modulo 3 is 0. So, and what is the length of this? 3. So 3 is answer. And yeah, 3 is the answer. Same with k. Go till write 6 ones and it divides 7 divides that. Return 6. For 2, it's -1. So yeah, this again, like there is nothing much I have to think in the contest, because I have solved uh, I think I have solved 2 3 questions with similar manner where you have to play with the reminders. So um what is the intuition, like first initially what came into my mind was, what is max length possible, what is the maximum length possible, because what can be the maximum length? The maximum length can be, since the answer again here we have to return, okay, first I have seen it the constraints, and k is 10 power 5, and the maximum data type that is in the Java is long. It has 19 digits, so 19 ones is the maximum number that we can have. So what I thought, for each of this, let me do a binary search from 1 taking as low and 19 as high, and for each mid value I create that number, and if I see if it is modulo is 0, if it is not I shrink, if it is yes I go right side, something like that based on that condition. But this is wrong. It's not question mark, it's exclamatory mark. This is wrong because here, yeah, again 1 to 19 are sorted, but are you that's the mistake with the sheets. If you see if you solve the questions that are from the sheets, like if they say, if the input is on sorted order, apply binary search there. No, this is wrong, because yeah, I used to follow those sheets. That's why I made a blunder here in thinking, assuming that this is a binary search question, but it's not, because binary search is not is was never about sorting. Binary search was about eliminating the half of the potential result, like eliminating the half of unpotential result, unpotential input, focusing on half potential of that result given input. So here, let's say 1 plus 19 by 2 is 10. So if my number, this 10 ones, if this 10 ones modulo k is not equal to 0, this doesn't mean there is no answer in the left side. Again, let's say if you take 7 as length, if you take k as 7, if k is 7, 7 doesn't divide this. That means, should I go right side? No. Should I go left side? Yeah, I have to go left side, but how can I decide? Um, maybe take some other k value. K value, let's say 237. 237, I cannot take it on, like I cannot go to right side thinking that answer is not in the left side, because that 10 digit number fails. It's not guaranteed, right? Divisibility can be anything, like it can number can be on left or right. You cannot potentially eliminate this. So that's why binary search is wrong, and I'm wrong about that. Then I thought it's just 19 numbers, iterate from 1 to 19, for every number make a number using while loop, and check if it's modulo. That's a very costly thing, and integer overflow can occur, right? Because say if your number is too long in the denominator, and in the numerator while appending you create a value called as num and long, and it just overflows. It's And there is an upper limit of num till how much, there is upper limit 19, sorry, but that's a wrong approach, right? It doesn't work. Now what to do? This is like play with reminders. So if we are doing div operation and using div operations result in next successive operations, play with reminders. Yeah, this is what um, this is what makes this is what avoids the overflow of integers. And I think in one of my previous streams where I discussed about the contexts, I proved by taking the same numbers, like 1, if you do modulo with 3, it's 1. So 1 into 10. You want to build the next number, right? Instead of building 1 into 10 plus 1 equal to 11, instead of again doing 11 into 10 plus 1 equal to triple one, what you can do here is do it modulo 3 here. 11 modulo 3 is 2. So use your 2 here. Okay, this is triple one, right? If you use 2 here, 2 into 10 plus 1 will become 21. Both the numbers are modulo divisible by 0. Triple one and 21. Instead of using the exact number that you got from the previous number to generate the new number, you can use the remainder of the same thing, because again, like you are doing modulo operation there, and again downside also you are checking for the division modulo. If it is giving the same remainder, its remainder also will give the same remainder. That's the whole point. And since I have mentioned that I have seen this question, kind of question earlier also. So there is a pigeonhole principle. Like they tell always, you always, I don't know proof of this, but always the number will have less than or equal to k digits. Yeah, prove me wrong. Yeah, like since I cannot prove this correct, at least yeah, negation of that, you can prove me wrong. So for input 7, what is the answer? 6. For input 3, 3. There is no case or situation where the number of ones is greater than k. It always lies less than or equal to k. And yeah, like that time I ignored the proof, and today I after the contest I went to Wikipedia and tried to understand the proof, and it's yeah, I think I have to go through it again. Yeah, if you see, the code is simple. Like initialize remainder to 0 because you need to check from the value 1. So remainder equal to is the same thing. Instead of, we were not doing this, we were just doing this. Just do this whenever the remainder is 0, right? As here. Here the remainder is 0 for triple one, for length equal to 3. When your remainder is 0, just return that length. And otherwise, if you never met, return -1. I think with 2 you will never meet. Let's check. So 1 modulo 2 is 1. 1 into, no, there is no point of doing 1, because 1 1 1 and everything will be 1, and you'll be getting the same numbers, 1 11 triple one. That will never be 0. So yeah, that's why do not do it 1. You can try it with 7. Now I don't have that much time to show. You can do it with 7. That doesn't work. Yeah, yeah, again this is a easy question if you would have seen it before. Otherwise it's a tricky one. What is this? Let's see question number 3 quickly. Question number 2, this also I got accepted. Let's see question number 2. So you are given in, I can draw this rather than telling this. Yeah, let's go to new. We'll take notebook. Okay, it's bad. Let's go to isometric. I think color I cannot choose, so let's go to grid. It doesn't matter, right? Wherever we're drawing. Take pencil. Width will be this much. Yeah. You have given 5 integers and 2 items. C1, C2. No, oh, why am I zooming this? Okay. Yeah, we have two things, cost one and cost two, and we have something called as cost both, which is the cost. What is this cost two? Okay, you can buy from type one and type two, and each type will cost one and cost two, and with cost both, you can buy either of them. And there are need one number of things you have to purchase from type one, and need two number of things which you have to purchase from type two. Um, we need to totally take at least need one and need two from the type one and type two respectively. Return integer representing minimum possible total cost to achieve these requirements. Yeah, this is the question. And if both need one and need two are zero, we cannot take this cost or we cannot take this cost. And so yeah, that's the base case that I can think of. And luckily it's also given in the question that if both are zero, you cannot purchase anything, so return zero. Now, let's say need one is two. uh, how to decrease this? Okay, I don't know how to reduce this. Okay, let's not worry much about this. Mm, let's write here on itself. So you need to purchase each type with minimum of need one quantity from type 1. Why rupees here? And need two quantity from type 2. So what is the optimal way for this? Like if you think greedily, I can use, if I can only take, so there is this cost both. If this cost both, um, let's say if this cost both is less than cost 1 plus cost 2, I can take minimum of these two, because if I need 2 and 3, and let's say if I take integer 2, and if I take 2 from this and 2 from this, with these two which are common from C1 and C2, I can either purchase this with cost both or with cost 1 and cost 2 respectively. So if you can see here, the cost minimum I taken from need 1 and need 2, and after taking the common things, these are the leftovers, like from each need of the type. So the initial cost will be the minimum of these two, like initial of this common things. Either I buy both types using common cost, or I buy using cost 1 and cost 2 respectively. So it will be common need into, I need to pick among the common cost and a minimum of common cost and combination of these two, into min of common cost and cost 1 plus cost 2. This is the initial, right? Because if my cost one plus cost two is lesser than cost both, in this case my cost one plus cost two is lesser than cost both, why will I give 15 rupees and purchase two things? Like 15 into 4 will be 60. But if I purchase need one with 5, 5 to the 10, and need two with cost 2, fourth is a 12, it will be 22. 22 is less than 60. So I can, if I'm getting it in 22, why will I go to 60? So that's where we are eliminating this. And yeah, why cost 1 plus cost 2? Because um, need, because we are taking common, right? Here if we are subtracting, the minute we are taking minimum of these two, one thing will become zero. Because yeah, I think that's intuitive. If you are taking minimum of these two and subtracting the minimum from each of the number, one will become zero, one will be left over zero, and we need to take care of the other leftover. So here, I think till here I explained. Now for the leftover, we need to decide. Okay, now we shopped for common things greedily. Now we need to see for leftovers. Now for the leftovers, here we have calculated the difference, like need leftover 1, need leftover 2. If it is 0, the leftover is 0, we don't do it. If it is not 0, we do it. So how do we do it? If leftover is 0, skip. Else, what will be the answer? So leftover into min of common cost comma cost 1. It depends, right? Because let's say if leftover 2 is there here, we want to buy it with the cost 2. If leftover 1 is there, we want to buy in cost 1. So that's why here I have written for cost 2, or you can here even write cost 1 or cost 2. Yes, agent is smart. So yeah, again, just written the total answer in the last. That's the answer. So yeah, even I made a blunder over here by checking, no, by skipping this if condition. Then I ran this and it failed here, because then I came to the fact that when you're subtracting minimum of a comma b from a and b, one will become zero, and you don't need to handle for that. You only need to handle for this. So yeah, uh, that's the three questions. This is a good contest, and yeah, I was able to solve three questions in this. Again, like, don't bother too much about how much is your rating and how much is your ranking, what other people are doing, whether they're cheating or like that. Just see how frequent you are going. If you see, it's not too show too much about scores. First, I used to solve only. If you go to second page, I used to solve only one question. First three contests, and my ranks are pretty bad. Then I started solving two questions with some penalties, and you see the time, two questions with two penalties, with four penalties, with penalties. Slowly, penalties got decreasing, and yeah, the questions I solved got not increasing but constant. So yeah, don't focus too much on that. So yeah, I think that's for this stream, and I think that's all for this stream. I have discussed about three questions, and the fourth question is digit DP. I post my dinner whenever I'm free this week after my work. I'm definitely learning digit DP because I cannot lose one more question. I think if people know, if you know digit DP, right, or if you have seen that digit DP thing, that question is easy to implement. There is nothing much maths to implement there. So yeah, and yeah, like what is next in my channel? Like this contest I'll be posting. Last week I gave contest, and those are pretty easy. So I think you would have either done or you would have seen solutions online, something like that. And yeah, I couldn't do streaming. um yeah, what's next in my channel? It's like, uh why is it coming like this? Okay, what's next in my channel? um Currently I'm exploring Kafka, the data streaming platform. And yeah, like, the interest on search is always will be there, and I'll be, for each stream every week I'll be dropping one search strategy, like phonetic, fuzzy, or zigzag, whatever I will be exploring. I'll be sharing that. And after some streams, if I'm comfortable with Kafka, I think I'm planning to start what is Kafka, what does it work, from how I understand it, and yeah, things like that. It's one of the most widely used uh, service. Kafka is one such good service. Yeah, I think it's late, dinner time. I'm ending my stream. Thank you.